Hi, very good day. Today we're going to see lab 3, which is free convection. Before going any further, let me introduce all my teammates. Okay, my team consists of 4 members, which Muhammad IRFAN bin Muhammad SHUKRI, MUHSIN AMILI bin NOOR, me, RUSHAN, anak laki Ranganathan, and Muhammad AIMAN bin RAZAK. Okay, this is the table of content of our report, which includes the theory, objective, equipment and apparatus, procedures and methodology, safety precaution, results, discussion, and conclusion. Next, let us look at the theory. Well, what is free convection? Free convection is something which occurs natural, or it is also known as natural convection. It's a mechanism or type of mass and heat transport in which the fluid motion is generated only by density difference in the fluid occurring due to temperature gradients, not by external source like a pump, fan, suction device, or etc. In free convection, fluid surrounding a heat surface, heat source receive heat, becomes less dense and rises by thermal expansion. Thermal expansion of the fluid plays a crucial role. In other words, heavier components will fall while lighter or less dense components will rise, leading to a bulk fluid movement. The picture on the right shows an illustration of the natural convection or free convection, where heat from the egg rises up and the hot egg cools down. Okay, next let us look at the objective. The objective of this experiment is to compare the maximum temperature each surface reaches for a given input power when in free convection. Next is to show the link between power and temperature on the pin and fin heat transfer surface when in free convection. Okay, this is the equipment that we have used to do free convection, and this is also known as a free and forced convection heat transfer equipment. Well, this equipment operation we shall show even further in the procedures. Okay, before starting a lab, safety precaution is very important, and the safety precaution should be taken so that there would not be any unwanted injuries or any unwanted lab results, or your lab results are mixed up. Okay, firstly, no food or drinks are allowed. Next, proper PPE, personal protective equipment and lab attire is to be worn at all times. Stay focused and aware of your surrounding. Don't play around in the work area. Fifth one is ensure work area is clean and tidy during and after work is done. Okay, before and during after work is done, you should perform 5S. And if there is any accident, inform to the engineer in charge or to your lecturer. Check all joints and connections before starting the lab work. For example, if it's a electrical fitting or a water fitting or a pressure fitting, you should check all joints and connections to avoid unwanted incidents. Next is follow all safety operating procedures of the equipment before starting work. Okay, to follow all safety operating procedures, one should go through the lab report thoroughly to know the correct way to start up the equipment and the correct way to run the equipment and to get results. Okay, next, wear gloves when handling any heat. Your hand is very valuable, so it is preferable to be wearing any gloves or some sort of protection when you're doing experiment related to heat. And also maintain a safe distance and sanitize hands before and after using the equipment. Okay, this is the add-on for the recent COVID times, where COVID can be transmitted through any surfaces. So you should be you should maintain a safe distance and sanitize hands. Okay, but most importantly, please wear a mask in a confined space. Okay, thank you.
So my name is AMIR. So today me and my group will make lab about free convection.
So first thing we need to do, open the switch of the heater on the back, and then you open the switch over here.
And then free convection is about no fan and natural airflow come into top and hit the fin, and we wait after system can detect the data.
After we turn on the system, the free convection lab, we are going to take the data starting from 0 watt. You can see from here it's 0 watt until we're going to 50, increment by 5.
Hi, for the free convection, we're going to record the data for the power from 0 to 50 watts. Okay, it's going to be recorded for the surface temperature, duct inlet, and also we are going to record the temperature difference. This is going to be done for the pin surface. Okay, our data will be recorded from this part, which is the T1, T2, the airflow, and also the power. The power will be increased using this knob here.
So after we done the test for pin surface, we change it to pin. So first thing first, make sure the heater is turned off.
Okay, next we are going to change the surface from pin to fin for the second part of the experiment. Okay, so we are going to remove the pin plate from the top. There are 2 screws. We have to loosen 2 screws. Loosen the screws up here. Be careful with the surface because it is quite hot. So once we have fitted the fin surface, we lock it and then we screw it here, and then we take this wire. We carefully remove this. You have to be careful to hold this part and not this part, because when you hold here, you might disconnect the wires accidentally. Okay? Detach your wires to T2. This is the wire for the fin. Connect this first, and then screw in your heater element. Then you have to on to test. Okay, once installed properly, once everything is installed properly, you can see the temperatures ranging from T1 to T3. Okay, you have to wait for a while, let everything to stabilize, then we can conduct the experiment. And the power for this will be 15 watts. This will be repeated using the pin and also the flat surface. Okay.
Very good morning and good day to Professor Zahir. My name is MUHSIN Penusfi. Today I'm going to present the result for our experiment of free convection. So for this experiment, we have conduct on 3 different surfaces with the fixed power, which is 15 watt. So the 3 different surfaces is flat plate, pin and fin. So from the experiment, we get 2 sets of temperature data from the equipment, which is TS or T2 and Tin or T1. So for this table, we have to calculate the differences, which is TS minus Tin. So the flat plate we get different is 41 degrees Celsius. For the pin, we get 17.6 degrees Celsius. And for the fin, we get 25.2 degrees Celsius. As for the next slide, we have calculate. As for the next slide is the data or result for heat transfer surface for pin. The power is not fixed. We take the data from 0 watt until 50 watt. So we get the different sets of data for T2 and T1. We have to calculate the TS or the difference, which is TS minus TE. So for the 0, we got 0.7, and 5 watt we get 3.8 degrees Celsius. So and 10 watt we get 6.2 degrees Celsius, and 50 watt we get 5.4 degrees Celsius. As for the next slide is the heat transfer surface for fin. This also is not a fixed power. We have collected the data for T2 and T1 from 0 watt until 50 watt. So the only thing we have to calculate is the difference, which is TS minus TE. So for the 0 watt, we get 9.2 degrees Celsius. For the 10 watt, we get 12.9 degrees Celsius. For 20, we get 23.5 degrees Celsius, and so on until 50 watt, which we got 53.5 degrees Celsius for the difference. For the next slide, with the enough data and result for heat transfer surface pin, we can plot the graph of temperature difference versus power for the pin surfaces to get the gradient, which is 0.6791, and the intersection is 1.0227. For the heat transfer surface pin, also we can plot the graph of temperature difference versus power with the help of the calculated data and the data we get from the equipment. We can plot the the graph. So we get gradient of 0.9935 for the fin, and the intersection 4.9545 for the fin surface. That's all for me, and thank you, and assalamualaikum.
Hi and Assalamualaikum. I am IRFAN. So I will talk about question fixed power in discussion. So first is create a suitable chart for your result. Compare your result for each surface. Which surface create the highest temperature difference in film convection? What can you say about this surface? Based on the bar chart, the flat plate is the highest in temperature with 41 Celsius. Meanwhile, second is fin, and the lowest in temperature is pin. So the reason why fin and pin has lower temperature compared to flat plate because the design surface for pin and fin effectively increase the available heat transfer surface area to help transfer more heat into surrounding area. For second question is, give an example on application of the surface you mentioned in any system that you know. So, all the three surfaces can be found in heat exchangers. Heat exchangers all work by passing in hot fluid and a cool fluid across opposite side of a piece of metal. Each design are more efficient than others depending on the application. Additionally, pin surfaces are used in air conditioning, heat pump, refrigeration industry, automotive and aerospace application.
Hi, Assalamualaikum. My name is Muhammad AIMAN bin RAZAK.
So this is our graph of temperature difference against power for pin and fin surface. As we can see from the graph, the temperature was directly proportional with power and have a positive slope. So from the gradient, we can predict that for pin surface, as the power increases, the temperature difference will increase with less significant value due to the gradient from the graph, which is 0.702, while the temperature difference on the fin type surface will increase slightly due to the gradient value, which is 0.975. So this is because fin surface has an expanded surface to enhance the transfer of heat into the surrounding air. So, two suggestions that we can take to minimize the time to stabilize the surface temperature. First, we need to make sure the hole on the side is completely closed with the magnetic cover. And lastly, it must be conducted in a well ventilated room.
Lastly, I will talk about conclusion. First, we are able to learn heat transfer concepts such as conduction, convection, and radiation. Through the lab, we are able to apply basic law of heat transfer by natural convection on various surfaces being investigated. This lab enables us to understand on how convection occurs on different surfaces. We are able to identify the data which connect temperature and power which act on different surfaces. Lastly, the pin type surface has better convection heat transfer compared to the fin type and plate surface. That's all from us. Thank you.